Have you ever wondered the answer to one of the most asked questions in scientific history? Is Pluto a planet, or is it a dwarf planet? And why have scientists debated over this topic for such a long time? Well, today, I'm going to try and persuade you as to why Pluto should be considered a planet and why further scientific advances have proven that it is not a dwarf planet. So first, let's talk about what makes a planet and what makes a dwarf planet. Well, planets like Earth and Mercury and Venus are active. They have volcanoes, they have glaciers, and they have movement underneath their crust. Dwarf planets are more of inactive, large spherical bodies in space, meaning that they do not have plate tectonics and mountain ranges or glaciers. They're more likely to be just flat land. So let's talk about what a planet really is. What makes a planet? Well, a planet is not defined by its particular shape nor its size. We consider bodies in space planets judging by their physical properties, such as ice volcanoes, lakes of methane, and even magnetic fields, which is why things like asteroids and comets are not planets, because they do not have magnetic fields, nor do they have volcanoes, lakes of methane, mountains, etc. NASA's New Horizons mission did a flyby of Pluto, and they took pictures of complex geographical surfaces on Pluto, says Greg Fletcher, a prominent figure for NASA and leader of the YES program, or Young Scientists and Engineers program. This is a picture of the glaciers on Pluto. We can still see the glaciers moving and eroding parts of Pluto today, even though most of Pluto is ice. Also, methane has been linked to areas of high altitude, like the top of Mount Everest. Using methane spectrometry, we're able to determine where mountain ranges are on Pluto. Like in this picture, the ridges are all mountains on top of Pluto. Decades ago, Pluto was considered a dwarf planet in 2008. However, in 2015, when New Horizons did the flyby, it went back to being a planet up for discussion. NASA recorded that parts of Pluto's crust actually move, which can only be explained by one reason: plate tectonics. Much like Earth, Pluto is active underneath its surface. It has a mantle with magma that moves and moves the plates on top of Pluto, creating fault lines, ridges, mountain ranges, etc. It is no surprise that plate tectonics is one requirement for something to be considered a planet in space. So let's summarize some of the most important points. There are many reasons Pluto should be considered a planet, like its plate tectonics and the fact that it's also bigger than other dwarf planets. Thanks to recent scientific advances, like mass spectrometry, we are able to dig underneath Pluto's surface and prove that it is a planet. All this information is useful not only to correctly categorize Pluto, but to help us make sense of our world, because we do that based on how we define and describe things. If we do not define and describe things right, they won't understand our world. So it only makes sense that they should be reported in a correct and meaningful way. Thank you.